Thanks, Lena, and welcome everyone. So in this session, we're going to explore AI and mineral processing, but not the hype. We've got these 4 experts who build it, use it, and break it or fix it when it breaks. So I'd like to start the session with in the big picture. So a question to all panelists. Could you please describe your vision for AI in mineral processing? And if I visited your site in 2035, who would be there and how would they be interacting with the AI? And then could you also relate what you're actually doing today to realize your vision? So start with Neil.
Start with me. So, so really, I have no vision for AI in the future. What I have a vision for is to gain business value from the operation. And what I see is that AI is one of the tools currently that we're able to make use of to gain that business value. So if you were to look at my plant in the future, then what I'd hope you would see is you'd ask the question, well, how are you doing? The people would say, well, we lost $200,000 yesterday because of this. And the AI then would be seamless, but would be able to be producing that information to tell you how you're going. So what I do is ask the questions to try and help derive that business value. And it's those business value items that then we look at and analyze to sit and say, what are the most appropriate tools to use to solve that particular problem? Be that AI, be it some sensor, be it anything else, those are what we really should be focusing in on.
Thanks, Neil. Paul?
All right, it was always hard to go after Neil. I think the way that we look at AI is a little bit different from some of the other practices around AI. So we've taken a little different approach. So if we were to cast ahead around 10 years, what we're trying to do is to build a system or a series of AI systems that enhance the human operator and maintainer. So making them more usable in terms of what they need to do to understand the process. So if something breaks down, they can ask the plant, what's wrong with you? And the plant will be able to tell them exactly what's wrong, what needs to be done, the parts, how long it took to fix last time, and those kind of things. But also a little bit predictive in terms of suggesting that, things aren't quite right. Maybe you should go and have a look at this. But also if you have a new operator start or a new maintainer start, then they can ask them questions like, well, how does this work? And then it explain to them why it works and why we do certain things like that. So enhancing the humans that you have within the processing plant is kind of the direction that, we'd like to see AI take.
Matt?
Thanks, Grant. I think I'd go down a different path, and that is if you came to the plant, I would suggest that we'd be doing it on a virtual environment, and we won't actually ever be physically there. I'd also suggest that actually there will be nobody on those plants at all. And I think the plants themselves will be self-running, self-regulating, and that would be an augmentation of what is capable today. And I think the future is actually how do you create a synthetic fabric that actually converges AI, digital, soft sensors, and human in the loop to actually create that future. And certainly the work that we're working on is linking humans into that loop and bringing soft sensors to reality. And I think certainly that future will be augmented. And I don't think we'll have humans on plants going into the future because it'll be safer for them not to be there. And plants won't break because the systems will be modularized, the robots will replace them. And so I don't see humans being required on sites into the future.
Oh, thank you, Matt. Iain?
Well, it's always fun to go last, isn't it? Thunder stolen on all sides. If you came to my plant in 10 years' time, I think you again would see very, very few people there, very few workers. I don't think there'd be nobody, but I think the numbers on the plant floor would be much reduced. that doesn't mean the jobs would actually go. I think the jobs will just transfer. So remote operations, being able to work from any location, that's really going to be the major shift. Get rid of this FIFO type environment. I've got a son-in-law who's a FIFO. He hates it. He's away from family, doesn't get to see his kids. Yeah, the money's great, but money's not everything. So the idea of getting people away from the mine site, not just for the quality of life, but also for safety issues. If they're not on site, they can't really be hurt easily. And that's, I see, where the facilities will actually be heading. The other part of that is really the role of AI in these new mine sites. I feel there'll be more advisory. I may be a bit of a pessimist here, but I think we've sort of reached a plateau of AI. We've had this massive increase in its ability and capabilities and accuracy over the past couple of years. And I'm not saying it's not going to continue to improve. It will. But I don't think we'll see that dramatic change that we've had recently. There will be a continual fine-tuning and improvement. That'll allow us to use it much as we're trying to use it at the moment in the foreseeable future anyway, in an advisory capacity. So I really see that if an operator has a problem, they can ask advice from the AI. If the AI picks something up, they can alert the AI they can alert the operator that something doesn't quite look right, but it will still be the operator to make the decisions. I trust humans a lot more than I trust computers. I've been working with them since the 70s. So I think I know them pretty well. But if there wasn't a pilot in an airplane, I wouldn't be getting on it. And I think it's the same in our plants. If we don't have that human aspect, monitoring and maintaining and supervising, there isn't the trust there now, and I don't think there'll be trust in the near future to completely rely on it.
Thank you. So for quite different visions and pathways, but I think a common feature is the human in the loop, and that's really the theme of this session. And we'll be exploring the sort of the who's and the whys with our distinguished panel in a minute. But perhaps just a quick story to sort of frame those questions. So let's pretend that my next step was to recruit a team of AI experts for my readiness and get my mineral plant ready. And all I had was the recording of this session for the training data for the AI model. So if I went over to Claude and said, hey, Claude, what are the essential traits of an AI leader in mineral processing? In his sort of prelude response, he would say that there are 80% correlation with between AI expertise and 4 traits. So white males who speak English, who sit on stools and wear glasses. And then he would say there's 100% correlation with facial hair. So he's unable to attribute causation. Claude would proudly conclude that what I should do, that the beards cause AI expertise, and that I should go out and recruit men with beards. So we all know that that's a ridiculous. We all know that's ridiculous, but not Claude. And here's the kicker: if somebody actually followed that advice and pick people with beards, that would reinforce the loop and reinforce the bias. So the message for me really is that AI can find the patterns, and we've heard that from other speakers, but it's really the humans that assign the meaning. So no need to worry. We selected today's panel based on their deep domain expertise rather than their grooming alignment. Although from a statistical point of view, they are a data danger. So let's first talk about the elephant in the room, which is mindset. So a quick question for Matt. What's the single most important mindset shift required before you even think about embarking on an AI journey?
Thanks, Grant. I appreciate the grooming advice as well, so thank you. I think the most important thing is have a mindset of curiosity. What Grant said is absolutely true. I mean, I gave a lecture the other day, and I was actually, as part of that lecture, I was arguing with Claude. And the argument was the differential between using AI to write code and also write a book. And my argument with Claude was I wanted to write a book. So Claude helped me write the book, and it said it wouldn't because I wasn't going to acknowledge Claude as being the author. Yet if I was to say I could use AI to write an algorithm, that's not a problem. So it's to do with understanding of context. And the reason why that's really relevant, particularly within this room, is understand the mindset, and be curious around what you're dealing with. At the end of the day, the famous saying, all models are wrong. It's just that we don't know how wrong they are. It's very, very true with AI. AI is implicitly wrong. But if you have a good framework, good governance, good ethical AI, etc., that will be a very important step. But ultimately, if you don't set the right governance and the right standards and the right culture within an organization, your implementations will fail. And I think getting that right is incredibly important. That mindset about how do you work on that? It's a journey. How do we be curious? How do we be authentic? But also, how do we have the right governance in place is really important to drive the right mindset within the organization, because not the individual, it's that collective tacit knowledge of the organization you have to get right.
Thanks, Pat. Neil, are you seeing it any different?
So look, I really see it very, very similarly. I would like to sort of add somewhat to that mindset is that you should really first off think about the physics of the situation, right? So rather than sit and say, let's just throw AI at it and deal with the data, we should look and say, well, we understand that it takes a certain amount of time on a conveyor belt for stuff to travel that distance. Let's make use of that physical aspect of the process before we then elevate to sit and say, well, now let's use AI, or at least when we get the answer back from the AI, we anchor it associated with the real world situation. Now, I want to give an example. It's not actually mining, but I'm building a motorbike at the minute, and I asked ChatGPT. I said, how should I design the electrical circuit on this? And it came out with some reasonably sensible suggestions. And then it said, do you want me to build you or draw you a circuit diagram? So it did, and it connected the positive and the negative of the battery together. Right? So now, if I hadn't understood that that's not a particularly sensible thing to do, then I could have gone ahead and blown up the battery quite nicely. But I understood that and said, oh, you've connected the positive and the negative together. And it said, oh, yes, glad you pointed that out. And then it came up with all sorts of things. So the biggest mindset is very much what Matt was saying is don't trust it, right? The AI doesn't know what it doesn't know, right? So bear that in mind when you start to think about implementing.
Thank you. That's shocking. So unlike growing a beard, getting an AI system up and running requires intervention, conscious thought and effort. However, once we got the mindset right, the really big hurdle next is data quality. And that's where the adage sort of garbage in, garbage out really reigns supreme. So, if AI gets confused about beards, imagine what's going to happen when it gets noisy plant data. So this question for Iain, in mineral processing, data quality is already a huge challenge. Now, in your experience, where do AI models tend to break down because of poor data?
They break down the same as any other system with poor data. As you said, it's garbage in, garbage out. We really need to try and mitigate the errors that we're getting in our data input. Now, I should point out that I'm not a miner, I'm not a metallurgist, I'm an electrical engineer who plays around with medical systems. And it may sound that that's a little bit different, but it's not. When we're playing with medical systems, we're sensing the information on a human being, we're taking action on that and feeding it back to the system, so like a dialysis machine. And it's really very much the same as the mining process control. If we have noisy sensors and it's giving us the wrong potassium level on a dialysis machine, we'll kill the patient. We have the same problem if we're getting the wrong temperature measurements. We could end up killing some people as well. So it's critically important that we know that our information that we're getting in is correct. And I know I'm probably preaching to converted on that. But how do we do that? Well, there's lots of different ways, and what we're trying to propose is a multitude of sensors. And I think you said it, collect everything. And that's exactly what we need to do, because if we can collect everything, we can find possible correlations between what we think are non-related pieces of data. And we can use those to confirm or validate other bits of data that we're getting in. So, simple example, we look at viscosity. We've got a certain viscosity reading. we can estimate what the temperature is. Is that the temperature we're actually reading? If it's not, one of these sensors is a bit askew. So by taking everything that we can get, reading that in, and then cross-referencing and looking for patterns, which is what AI is really good at, to find correlations between what we think are uncorrelated pieces of data, we can improve our data reliability a great deal. And we're working on that through our open system that we've just installed that allows us to add anyone's sensors, anyone's pieces of equipment, and gather data that you wouldn't normally gather.
Thank you. So really, bad data is like a bad beard, ruins everything.
No such thing as a bad beard.
So even clean-shaven data still harbors biases. And as we saw in the beard example, data is inherently dumb and devoid of causation. And left to its own devices will happily amplify its biases. So that the mitigation is the humans in the loop, which is sort of what we're here to talk about. So this question for Paul: how do we design AI to complement human operators rather than replace them?
Yeah, that's a good question. So I think one of the processes that we look at is where is an AI tool going to provide the most benefit to the end user. And so when we talk to customers, we focus on the things that they find annoying, the things that stop them from doing the good stuff, the creative stuff, the stuff that they feel is important. And so, and a lot of that stuff is the mundane, repetitive stuff, which AI is actually pretty good at. So that's kind of the low hanging fruit in that respect. So that's kind of where we start, and then we look at well, what else can I do? What can I do to speed up the work that you do and enhance some of the outputs that you do? Is part of that process. But the other thing we realize, and I spent a lot of time in autonomy and robots before. And one of the pitfalls of autonomy is you go and put autonomous vehicles in, you get rid of people. But there's a whole series of tasks that those people used to do that don't get done anymore. And then so mining companies have had to go back and employ more people to do those things that the other people didn't do. So we look at the process to say it's very difficult to actually replace an entire person with AI because they do a bunch of stuff that AI doesn't do. And if you get rid of them, then it's going to cause other problems. And honestly, if you're doing it right, you should actually start employing more people. And so that's what we've seen since the beginning of the Industrial Revolution, is that if you get a uptick in productivity, then you create more jobs. And that's kind of the output in that respect. And it's finding the AI tools that allow them to be that much more productive, that we do more things.
Thank you. So, humans in the loop may or may not have beards, but what really matters is their capability, and it's the capability to understand AI's limitations and how to impose their domain expertise. So this question for Neil: when getting started, should a plant rely on an external expert to build the system, or should that task fall to internal staff, but they already have full-time jobs, keeping the show on the road? And to them, at the moment, AI is a black box, so a lot of learning is required, a steep learning curve, and obviously it could be quite painful. Or is the answer a hybrid? And if so, what's the most effective way of managing that relationship?
So first off, I'd like to reiterate around what I was stressing before, which is really find the value and then look towards what I call subject matter experts. So the first thing that you've got to do, if you say this has got some value, then test that out with the subject matter experts that you do have. If you can then identify that, then you're in a position to say, now, what tools do we again apply to do that? And having then determined the appropriate tools, then you can decide what is the best method of doing that. So rather than a blanket statement, go out to these people to do the AI, the answer really is it depends, right? And it depends on what you're actually specifically trying to achieve.
Thanks. Matt, are you seeing it any different, or
I know I pretty much agree with Neil. I
you're
think
boring, aren't you?
I know, but it's okay. I'll add to it. I think the most important thing though is to understand context. So if you don't understand the domain, don't understand the context, you can do amazing stuff, but you can get it wrong. And I'll give an example. So we did some work for Fiona Wood, who's a burn specialist, and we were analysing the data. And we were really excited because we found this causality and it was linking together. It was virtually one-to-one. And so we discovered that if the person had this compound in their blood, they would go to sleep. And we thought that was amazing. So correlation was one, and we thought we discovered this amazing thing. And a bunch of data scientists and mathematicians were really excited by this incredible insight. And we took great pleasure in going up to Fiona Wood and saying to Fiona, "Hey, Fiona, we've found this amazing thing. If they've got this compound in their blood, they go to sleep." And her response was, "Yes, Matt, they would, because it's actually called an anesthetic, and we would hope that they would." And for me, that has been one of the most telling stories I've ever had, where you can be as bright as a button and you can think AI is brilliant and all of that. But if you don't understand the domain, you don't understand what you're dealing with, you will make a horrific mistake. And that just so happens that we also found that if in that context, people actually had people at home they need to go back to, then they would actually get out of hospital a lot sooner. They would do their rehab a lot better, and they have a better outcome. But fundamentally, if you don't understand context and you don't understand how that data is being applied, very analogous to Neil's story with respect to the positive and negative, not only will it be shocking, but it will also be a complete disaster.
Thanks, Matt. So, the capability of the peoples obviously matters, and it matters a lot, but also the way they interface with the technology. But in this regard, I think there seems to be a bit of a gap. It's a bit of uncharted waters. So I'd like to ask Iain what role research and innovation has to play, for example, in framing queries. So there's a big difference between can we versus should we, and how can we error-proof the system with a poker-yoker type of approach to system design?
Well, I'll address first with how can we help industry, or how can research and development contribute to industry? In our case, we've developed a safe sandbox environment for industry to come to us and try things out that you wouldn't try on your own equipment. It's real-world equipment. It's completely open. It'll work with Yokogawa, Schneider, Rockwell, whoever you like. But you can use it in this safe sandboxed environment. But you can also expect an honest response because we're not selling you anything. We also have the ability to call on a large range of expertise. As I said, I'm not a metallurgist, but I tell you what, I've got a whole bunch of people who are in the office next door to me. We can call on chemical engineers. We can call on our friends from computer science, any sort of area that we need, and bring them into that particular project. So what we in particular can bring to the industry is the ability to experiment and try things out in a safe, unbiased environment. Well, one thing I will point out, we've got one of the greatest resources you could ever hope for, and I know there's a couple around here, students, well, past students over there. We have about 3,500 engineering students and another 1,500 odd computing students who don't know what's not possible. And that's really interesting because you can give them a problem and they will come back with a bizarre, weird, and maybe wonderful way of solving that problem. And sometimes it works, many times it doesn't. But it's bringing those young people in who have the imagination, who think outside the box, that can be really, really beneficial. The side advantage of this is you get to try before you buy, see what students are like before you actually go and hire them. So it's a good pool of talent to get. Apart from that, I think what can we do? Well, we can test those things out. We can run the digital twins that people were talking so much about nowadays that we used to call simulations, and they're really just a simulation on steroids. But we can create those for you. You can see them in action without actually doing anything to your plant. And we can ask those sort of questions which you may not want to ask. You don't have the resources to answer, such as, is it ethical to use AI in this area? Is this an explainable solution that we're coming up with? And some of the other core questions that need to be answered in the utilization of AI in industry.
Thank you very much. So we've covered the hairy issues of mindset, data quality, human capability, and systems engineering. So I'd like to sort of zoom out to where we started in the big picture again, but this time with some granularity around the humans in the loop. So a question for Paul. Given that we can buy the technology, but we can't buy the unicorns, Apart from beards, what attributes should plant managers be looking at today to develop or hire resources that support an AI initiative? After all, sort of change isn't for everyone.
Yeah, that's a tough question. Um, some of that is to do with getting that acceptance or the adoption of using AI tools, and I think a few people have alluded to it earlier in the fact that this technology is moving so fast now, where sometimes you see that industry leads and people lag. In this particular case, people are using things like ChatGPT at home to plan their holidays and do all kinds of weird stuff like that, and they come to work and they're not seeing it, and they're like, "What's going on?" So uh, there's a readiness already there to adopt it, and it's a matter of finding what you're going to use it for. And so a question that we often get asked is, we want to be doing something with AI, but we don't know what it is that we should be doing in this space. And so that's kind of the first step. So before you work out who you want to bring on board and how you want to do it, is you need to really decide what's going to be the biggest impact for us and where should we focus. And that's the first step. And then you'll find that it'll be probably like a self-fulfilling prophecy in that respect. You will find the right people in that space to help you doing what you're doing. But you need to look kind of internally to your organization to work out where it's going to be the best fit for you. And also, have a bit of a look outside to see what people are currently doing out there now. And I think another question that was asked was around, would you use one of the big four consulting firms? And having done some work with them recently, is they're just in much a mess as everyone else, So asking them, we don't know what to do with AI, what we should do, I'm sure they will tell you, but internally they're like, we don't know what to do with it either. And so that's kind of where it is at the moment.
Excellent. Thank you very much for that. So we've got a few minutes left for questions. So got a lot of people in the audience, possibly humans in the loop in the future. So if anyone's got any questions for the panel, please raise your hand, tell us your affiliation and then your question to the panel.
Hi, I'm Kevin Blom. I'm with Paul 412. I'd like to ask a basic question. What do the panel think AI actually is?
I cheated a little bit with that, and I asked ChatGPT, what is AI, right? And I mean, I can read out the answer, but so I'll read it out, right? So it said, artificial intelligence is a discipline focused on creating systems that perform tasks requiring human-like intelligence. Okay, so that's a very wide definition of what AI is. Now, within that framework, then I also said, well, what's machine learning? Right, acting really dumb, and he said, well, machine learning is a subset of AI, enabling systems to learn from data and improve autonomously without explicit programming. Right, so he said, well, in short, AI is the overarching field. Machine learning is a subset within AI. Now, I can continue on because then I asked ChatGPT what it is. So perhaps it's a bit of sales for ChatGPT, but it said, well, ChatGPT exemplifies AI and ML integration. It is powered by generative pre-trained transformer architecture, trained on vast text corpora using deep learning techniques. So, sort of somewhat make of that what you want, but basically, somewhat my answer would be, well, AI has been around for decades, right? It's actually nothing particularly new. And so has machine learning been around for decades, right? What is new is the ability of computers to actually perform the learning exercise to be able to enable it, right? And we can certainly dispute that with all of these data centers that are coming up that are consuming vast amounts of power to provide us with Copilot, ChatGPT, etc., etc. So I'm not sure I particularly answered it, but I've certainly posed perhaps a few more thoughts.
Anyone see any difference?
I think Neil's done a good job there. Yeah, I think ChatGPT did a great job.
That probably says more about it than anything else.
Any other questions for the panel?
G'day, Paul from Tornado Metallurgy again. This is quite a specific question for mining, but I suppose one of the challenges in mining, it's an aggressive environment. Things are always wearing, and as they wear, their performance profile changes. So some things, their performance improves as they wear, some degrade, and things are getting constantly changed. Is that a challenge that you guys see when developing these models? And how do you guys deal with that kind of noise coming in the data from these maintenance schedules?
Paul on that. As I say, Paul, that's a poor question.
I think that's a really good example of where AI excels. And there's a series of processes that you can derive what the answer is, and some of it is you build it through simulation, and some of it is you do it through learning. But it is a really good example of where I think AI will provide great benefit in going on in the future. And particularly looking at a larger subset of equipment and how things wear over a period of time, it'll learn better. There are some problems with causation, as we previously discussed. But if as long as you keep that human in the loop, that's a really good example of where AI can really push the boundaries in terms of what you can actually do around wearing parts and those kind of things.
Thanks, Paul.
I think we're at about
Time. Okay,
Yeah.
so obviously we've got the networking events. So if you've got any burning questions, anything's piqued your interest, I encourage you to collar one of our panelists and sort of explore the answers with them offline. So just like to thank all our panelists and their beards for their contributions.